Here we go. We have a question. Apply operations to make maximize score. So you have given an integer array nums and an integer k. Initially your score is 1 and you want to maximize your score by applying this following operation at most k times. What is the operation? We need to choose any subarray, choose any value between these elements with the highest prime score. What is the prime score? Prime score of an element x is equal to the number of distinct prime factor of x. For example, prime score of 300 is 3, which means 2, 3 and 5. So we have 3 prime numbers, so this is the prime score. We need to choose a number x with the highest prime score. If multiple such element exist, choose the one with the smallest index, right? And we need to multiply the score by x, which the number we have chosen, and we need to return the we need to return the maximum possible score. So we have given this and we need to apply the operation k number of times. First of all, choose any subarray. I will choose this subarray. This is a subarray, right? Now this is a single element. So what is the score? Score of 9 is only 1, right? So we have chosen this number. Then we need to multiply our score by x. We need to multiply our score by 9. So my score will be 9 at this point. The next subarray I will choose is this. The score of this 9 is 2. Score of this 9 is 1 and score of this 3 is 1 only. So it says that if multiple such element exist, choose the one with the smallest index. The smallest index is 9. So 9 is my x. I will multiply my score by x. So it will give me 81. Previous score is 9. Current score is 9. Current element x is 9. So my answer will be 81. I have applied two operations. So my answer, the resultant is 81. If I have given this subarray, we need to find the maximized score. So let's build the approach. So I have given this subarray. First of all, we need to find the score. Score of 19 is 1. Score of 12. 12 by 2, which will give us 6. 6 by 2 is 3. So the score of 9 is 2 only. What is 14? 14 by 2 is 7. 7 by 7 is 1. So again the score is 2. If we have 6, 6 by 2 is 3. 3 by 3 is 1. So the score is 2 only. If I have given 10, 10 by 2 is 5 and 5 by 5, answer is 2 only. In this case 18, 18 by 2 is 9, 9 by 3, 3 by 3 is 1. So the score is 2. Number of prime values is 2. So we got our score. So if I am selecting a subarray, then we can go left, we can extend it to the right. Then till when we can extend to its left. So suppose I have given x, this is my value, and I can go left, I can go right. So this will be different subarray, right? Obviously. So how long can we go left? What is the point? What is the point? So in the question it says that if multiple such element exist, choose the one with the smallest index. It means we need to select with the highest score, right? We need to select the highest score. If this value is the highest score, we cannot choose, we have to compulsory choose it. But if I have to select this value only, the score of this value is suppose x, the score of this value is something, then the score on the left must be less. Why? Because if this score is greater, then we have to compulsory choose the value on the left side. Yes, makes sense. But what if the score of the left side element is equal to the score of the current element? Then we have to again select the leftmost element. Makes sense. Till when we can go right? If the score is equal or less. In the question it says that if multiple value have same score, we have to select with the minimum index, so we will select this. So equal will make sense. What about less? If the score is less, if the score of this value is less and this value score is greater, we have to select the value with the greatest score, so I will automatically select this value, right? So if I select a value, I can go to its left, I can go to its right. What value should I pick first? I need to make my score as maximum as possible. So I will select the maximum value. So I will select the maximum value. So this value must be the maximum value initially. Then I can go to left side, I can go to right side. I will extend it to the left side, I will extend it to the right side. Make sense? Right. Now I will first select this subarray. Now I have selected this subarray. Now you get a point that how we will find the maximum element. For that we will use priority queue. So this is my priority queue and this is the maximum priority queue. It will contain two elements, two things. First is the value, which is nums of I. Second is the index. So it will contain 19 and 0. It will contain 12 and 1. It will contain 14 and 2, 6 and 3, 10 and 4, and 18 and 5. I will sort it based on the maximum value. I will sort it based on the maximum value. So let's sort it based on the maximum value. First value is this. Okay. The next value is this. The next value is this. Then the next value will be this 12. Then we got 10. Then we got 6. So this is my sorted, this is my maximum priority queue. Then the first value we got is this. So I will get this value. I got 19 and 0. What is my score initially? The score is 1. So I will multiply the score with the maximum value. We got 19. Then using this index, I will try to go left side, I will try to go right side. But in this we cannot go left, but we can go right. We can go right, but we want the right score to be equal or less. But we got right score as greater, so we will stop here. Yes, that's all. Then I will get the next value, which is 18. 18 and 18 and 0, 1, 2, 3, 4, 5, 18 and 5. First of all, I will multiply my score with 18, and at this point I have applied 2 times the operation. Then using this index, we will try to go left side, we will try to go right side. Can we go left? Yes. No, we cannot go left. The left score must be less, but the left score is equal, so we cannot go left. That's is the stopping point. We will stop here. The next value is 14 and 2. We got 14 and 2. First of all, we will multiply our value with 14. Next, using this index, we will try to go left side, we will try to go right side. Can we go left? No, we cannot go left because its score is equal. Can we go right? Yes, we can. I am on to this point. We can go right. The right score is less than or equal to, but we have already applied 3 operations. The k is 3. So we will not go left. We will not go right. Right. We will not go there. So this is the score, but it will create an issue. Let me select another example. So I have taken this example. in this my array is this, and the score of this array is this score is an array. Yes. Then the next thing is priority queue. So I have taken this priority queue. Then this is the maximum element. I have sorted it according to the element. So this is the element, and the next thing is the index. We need to select 15 sub arrays. 15 sub arrays. So I will select this 60 and 3. 60 and 3. It will give me this. Now we can go to its left, we can go to its right, but the left score should be less, and the right score is equal or less, right? So we will select this. First of all, my score. Then let's find the score. The score is 60. The score is 60. This is the maximum value. Then I will try to go left side. The score of this 15 is less. The score of this 15 is less, means this subarray is a valid subarray. Then I need to select the maximum value. The maximum value is this, right? The maximum value is this. So I will multiply with the value 60, right? It says that choose an element x between this with the highest prime score. So I will select the value 60 with the highest prime score. Yes. Then I will again try to go left. I got this. In this, the maximum prime score is 3 only, which is this, right? Which is this. So this score, I can go to its left. The left score must be less. The left score is less. So I can select 60. I can select 60. Again, I can go left. I can select this subarray, and in this, the maximum score is 3. The element is 60. Then I can go to I can no longer go left, but I can go to right. So the right score should be less or equal. The right score is equal to my current score. Yes, I can select this. So at this point, should I include 60 only once? No. At this point, I will select 60 4 times. Why? First is this. This is a valid subarray. 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 So at this point, I will select 4. Now it will create an issue. Obviously, you can write some complex code. So to find the left point, then this is my right point. So what I will do right minus left, which is the total number of subarrays. In this point, it is 4. Yes, 4. And 4 times I will apply 60, and I will add it here. Yes, but there's an simpler way to do the same thing. So first let me erase all this, and let me find the left point and the right point. Score is here. I will find its left point and its right point. What is the left point? I am sure that if my value is, if my current value is something, then I can go to its left with the score less only, and I can go to its right with the score less or equal. Yes, I am at this point. The score of this is only 1. Yes, the score is only 1. So I can no longer go left. I can no longer go left. So my left point is initially -1. Initially, every value is -1. Yes, but we don't need to fill it. The left will be filled. The left will fill algorithm will fill -1 automatically. So I will fill -1 here. Then I am at this point. I can go left. Can I go to this position? Yes, this score should be less, but in this score is equal. The score is equal. So I cannot go left. I cannot go left. I can stop in this position only. What is this position? This position. What is the stopping position? Stopping position index is 0. So let me write the index. Yes. So I hope you got this what I am trying to build. I will use stack here, and I will first add the value 0. I will then add with value 1. Yes, then I am on to this position 15. What is the score of 15? First iteration is to find the score, so I have built the score, or I have built the score before that, so I know my score array. Then the score of 15 is 2. I will look on the stack top. Is this index, what is the score of this index? The score of this index is 1. Can I go to that position? Yes, the score is less, so I can go to this position, so I will pop it. Can I move to this position? My current score is 2. What is the score on the 0th index? Is 1, which is less. The score should be left, so I can go to this position also. Again I will pop it. My stack will become empty. I can no longer go left, so I will put -1. It means I can go till -1 point, right? Then I will just put 2. The next value is this. I hope you got this is my monotonic stack. The next value is 60. The score is 3. What is the score on the stack top? Stack top, it contains the index. What is the score on that index? Is 2, which is less, so I can go to that position. Yes, my stack will become empty. I will place -1. It means I can go till -1. Then I will just put the current index. Yes, my next value is 30. What is the score of this? Score is 3. What is the score on the index that is present on stack top? Stack top index is 3, which is this. What is the score? Is score less? No, it is not less. It means we will just stop there. I cannot go the left side. I can just go till here. It means I am just I can just select this subarray. I cannot select the left subarray. I can just select this subarray. This is the stack top, so I will just place 3 here. This is my stopping position. I will stop at that point. Just place 4. I will go to this. What is the score? Score is 2. What is the score present on this index? Is 3, which is not less, so I cannot go left side. I can just go on index number 4. Add the current index. Next my index is this. What is the score? Score is 3. Score is 2. What is the score on the stack top index? Is 2, right? This score is not less. We cannot go on that point, so this is the stopping position of this subarray. That's about my left. Let's also build my right subarray. Right subarray is same, but in this it must be less or equal. Okay, so let's quickly build it. Initially my stack is empty. I am at this point. I can no longer go right, so it will be 7, which is my stopping position, right? Yes, just add 6. I am at this point. This score is 2. What is the score on this index? Is 2. Can I go there? Yes, the score should be less or equal. It is equal, so I can go there. Just pop it, and that's all. Just add the current index. What is my current score? Is 3. Can I go on that index? Yes, this score should be less than the right score, should be less or equal, so I can go there. That's all. Just add the current index 4. What is my score? Score is 3. What is the score on that index? 3 is 3. The right should be less or equal. So I can go there. just add 7 and just add 3 here. What is the score? 3. What is the score? 2. Right, 2. What is the score on that index? Is 3. So is it less or equal? No, I cannot go there. I will just stop on index 3 only. Then what is the score? I forgot to add 2. What is the score? 1. What is the score on that index? 2. Is it equal or less? No, it means I cannot go there. Just add the current index here. What is the score? 1. What is the score on that index? Is it less than or equal? Yes, it means I can go there. What is the current score? Oh, oops. What is the current score? 1. What is the score on that index? Is it less than or equal? No, I cannot go there. So that's all. This is my left and right sub array. Let me verify this. Yes, my left and right is correct. Then I have built my left and right sub array. The next thing I need to calculate. Okay, my k is not given. Let me write the k. I need to find 15 such sub arrays. Let me also quickly find the priority queue. So I have calculated my priority queue. This is my nums of I, and the second index is my I, right? So I have sorted according to the nums of I, means the first value which is given here. Then I will select the value. I will select this value. What is the score? Score is 60. Score is 60. And what is the point? Point is 3. 3. And how long I can go left? I can go till -1. So this is my left point. How long can I go right? The right is 7. So I can go 7, then -1. So this is my 7. This is my 7. This is my -1. What is the length? Length is 7 minus -1, which is 8. It means I can select 8 sub arrays. Is it correct? Let me check. First is this, then second is this. Actually this is not correct. 1, then 2, then 3, then 4. 4 is this. 4 on the left side. It means 3 minus -1, which will give me 4. So 4 on the left side. Then how many on the right side? Right side is 7. 7 minus the current index, which is 4. 4 on the right side. 4 on the left side. 4 on the right side. How many sub arrays can I calculate? 4 multiply 4, which is 16. 16 is the correct answer. 1, 2, 3, 4, right? Then 5, then 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 sub arrays I can calculate it. But how many do I actually need? How many do I actually need? So let me change it. Let me write 25 here. 16 sub arrays I can calculate it. But how many do I actually need? The actually need is 25. So I will just select 16. 16 is the valid. So I can select 16 times. So this 60 will be multiplied 16 times. So 60 multiply 60 multiply 60. How many times? 16 times. So 60. So let me change it. 60. This is the score. 60 will be multiplied 16 times, right? And 16 sub arrays I have already selected. How many remaining? 9 sub arrays remains. What is the next? The next is 30 and 4. The score is 30. The index is 4. How long can I go left? I can go left only once. Only once. Means the left of I minus the current index only give me 1. It will not give me 1. It will give me 0. So I will just, I think there's a mistake. No. this for left, this is for left, so it will give me 1, it will give me 1. How long can I go right? So 7 minus 4, it means I can select this, I can select this, I can select this. So I can select 3 sub arrays. So left minus right, I can select 3 sub arrays. How many do I actually need? Only 9. So 3 is less, I can only select 3. So I will just select 3 and 3 subtracted from here. The next value is 15 and 2. What is the so 15 and index is 2, index is 2. How long I can go like left? So it is 2, actually 3, it is 3. Then how long I can go right? Only 3. So which is this and this, 3 and 1. So I can only select 3 sub arrays, I can only select 3 sub arrays. So 3 sub arrays I can only select. The next is 6 and 5, 6 and the index is 5. How long I can go left? Till 4. It means 1 sub array I can select from this. How long I can go right? Till 7. So it will be 2. So 1 multiply 2, I can select 2 sub arrays. So 2 sub arrays from this, and 2 is subtracted from here, 2 is subtracted from here, and this is my current score. Then the next thing is 6 and 6, 6 and the index is 6. How long I can go left? Only 1. How long I can go right? Only 1. How many total sub arrays I can make? Only 1. How many do I actually need? Only 1. So I will select only 1 sub array, and at this point my k will become 0, and this is my score. And obviously this thing 16 cross 16 can be solved using superpower, which means a raised to power b. I will make a separate function, right? So that's all about the approach. Let's code this. So first of all, let's find the score. We also need n. The current value, and this is the value, and then we need to find the number. So let's say let's say 2. We are starting from 2, and it should be less than or equal to value. If it is divisible, if number is divisible by j, then score of I is added by 1. Then I will just half the number by I. If it is divisible, just divide the number by j, just divide the number, that's all, and it will give me the score. But what if we got 6? So 6 is divisible by 2, score is incremented. 6 is divisible by 2, it will give me 3. Then in the next iteration, j is 3, 3 multiply 3, which is 9. 9 is not less than 3. So if my value is still greater than 1, I will just add one more score. So I find the score, and I need to find the left point, and also need to find the right point. For this I need a stack. For that I need a stack, and while my stack is not empty, what is the leftmost point? The leftmost index score. So score on that index should be less than current score. So I can reach to that index. Then I will just add the left point. if my stack is empty, just add -1, then otherwise just add the peak point, and don't forget to add the index. So I have find my left point. Also need to calculate the right point from the right side, while this thing and score on that index should be less or equal than my current score. Then I can reach to that index. Again, if right of I, if it is empty, just add -1, otherwise stack dot peak, or don't forget to add stack dot push I. So I found my left point and the right point. Then I need to also add the elements in the priority queue. This is the priority queue. The first thing is nums of this is not nums, this is list. This is list. This is not an array. And sort it based on the bigger value O2 of 0 minus O1 of 0. It will sort it based on the bigger value, while priority queue is not empty and my k is still greater than 0. Find the answer. So initially let's take the answer in long, and we'll also need to apply modulus 1e9 plus 7, right? Just get the value, and this is the score. What is the leftmost point? What is the rightmost point? So just calculate subarrays. So we know the point. This is the, first of all, find the value. Value is present on the 0th index. The index is present on 1th index. Then left of the current index minus index. No. Index minus left index, because left is smaller. Yes. Multiply right value minus index, and before that let's convert it into the long. So we got our total subarrays at this point. It means the leftmost point, the current point till the leftmost point, this is the subarrays on the left hand side, and the total subarrays on the right hand side I've already calculated, and this is the total subarrays. Then how many subarrays do I actually need? So we also have k, and this is the total subarrays. So what I will do, I will just take temporary between the I will just find the minimum value between this and this, and just subtract your k. Answer. So it will be multiplied by the superpower. It means superpower value is multiplied by temp number of times. Just return the answer. That's all. Just find superpower long of a long of b. This value is integer, so just convert it into the long plus 0 and temporary is already long. We also need to apply modulus, so let me take the modulus outside. Right, if power is 0, so 2 with power 0 will become 1 only, or anything with power 0 will become 1 only. If power is divisible by if the remainder is 1, then take a outside. It means 2 raised to power let's suppose 13 raised to power 7, so I will take 113 outside and just subtract power by 1. Otherwise this is superpower, otherwise superpower a is multiplied by a and b will become half. Also need to apply modulus at this point, and modulus here, that's all, and a modulus here. Let's run this, and we have an error. The answer, so convert it into the integer. The video is a bit lengthy, so I did a mistake here, and after debugging it I figure out that in the left side I just add -1 if my stack is empty, and on the right side I also added -1, but at this point I need to add n. So that's all. Let's run this and I hope it will work. Let's submit it, and let's discuss about the time and space complexity. We have given this function, and in this function we have this for loop. The inner for loop will run till under root of the maximum value, under root of this maximum value, and in this loop it will be order of n multiply under root of maximum value under root. Then this left array, this right array is order of n only, this is order of n only, and this priority queue I am also adding the values, and it will contain n values. For addition or removal it will be log n, so priority queue time complexity will be n log n. What about this? It is also n log n. What about space? Space is order of n only. That's all. The video is already a bit lengthy, but it is worth it if you watch with patience. And that's all. The code is provided in the description box. If you guys have any doubt, feel free to ask in the description box. And thank you all for watching this video.